Looping in programming language is a feature which facilitates the execution of a set of instructions or functions repeatedly while some condition is valued to true. So Java provides 3 ways for executing the loops: while loop, for loop, do while loop. While all the ways provide similar basic functionality, they differ in their syntax and condition checking time. A while loop is a control flow statement that allows code to be executed repeatedly based on a given Boolean condition. The while loop can be thought of as a repeating if statement. Though while this Boolean condition is true, the block of statements in the loop body will be executed repeatedly. To write a definite loop, we initialize a loop control variable, which is a variable whose value determines whether loop execution continues. In this code segment, we have a variable LCV, and we have a constant, which is a limit 11. So the LCV is a counter, the first initialized to 1. Inside the loop body, it will display the counter, also increment the counter. So while the counter remains under 11, the loop will continue to run. The LCV will be output and increased. An infinite loop occurs when a condition always evaluates to true. Usually this is an error. For example, in this code segment, the message hello will be displayed forever because 4 is always greater than 2, so the condition is always be evaluated to true. So the while loop will continue to execute and the loop never ends. So we should avoid this kind of error. Remember to use the curly braces to enclose multiple statements in the loop body. In this example, we have 2 statements. The loop count is 1. It is compared to 3. Because it is less than 3, the loop body executes. So it displays hello. Also, it increases loop count. The next time loop count is evaluated, it is 2. It is still less than 3, so the loop body executes again. Hello is displayed, and the second time, the loop count becomes 3. Finally, because the expression loop count less than 3 now evaluates to false, the loop ends. Program execution then continues with any subsequent statements. To prevent the while loop from executing infinitely, the named loop control variable shall be initialized to a starting value, and the loop control variable is tested in the while statement. If the test expression is true, the body of the while statement takes action. It also alters the value of the loop control variable. It's updated the loop control variable. Then the test of the while statement must eventually evaluate to false. The loop can stop. In this code segment, it's the same mistake we should avoid. Inside the while body, there are supposed two statements. One is the system out.println hello, the displayment statement. The other one is the loop count update increment statement. So because it's lack the curly braces, the loop count variable is not updated. Just one single system.out.println is for the while loop. Hello will be displayed forever, so it's an infinite loop. So remember the curly braces to enclose multiple statements. Just like the if statement, the semicolon shouldn't be placed after the while condition. Otherwise, it's an empty loop. Then the subsequent statement will be executed. You can also decrement in the loop counter. So in this example, the loop is controlled by subtracting 1 from a loop control variable. We can also have an event control loop. So in this program, the loop is controlled by the user input. In this program, if the user enters number 1, the loop body will be executed. Note in the loop body, the last statement is response equal keyboard dot next int. If the user enters any integer value other than 1, the condition after the while will be evaluated to false. The loop will stop. The loop can be used for validating input data. Validating data is the process of ensuring a value falls within a specified range. For example, suppose we require a user to enter a value no greater than 3. This figure shows an application that doesn't progress past the data entry loop until the user enters a correct value. If the user enters 3 or less at the first prompt, the loop never executes. However, if the user enters a number greater than 3, the loop executes, providing the user with another chance to enter a correct value. Inside the loop body, you should have another input prompt. So user entry equal the input.next int. So actually assign the user prompt to user entry. When we say equal, it's actually not equal, it's assignment to the variable. So it gives chance for the user to re-enter. Also, we can re-evaluate the condition if user entry is greater than limit. A shorthand operator is a shorter way to express something that is already available in the Java programming language. Plus equal is addition, then do assignment. Minus equal subtraction and do assignment. Then multiplication equal multiply and assign. Division equal divide and assign. And the module equal, we get the module first, which is the remainder. Then we assign the value. We can have a prefix operator and a postfix operator. When a postfix operator is applied on a variable, the value stored in the variable gets incremented or decremented by 1 later on an expression. In this example on the left, we have an integer a equal 2, so we assign 2 to variable a. Then the next statement, a equal a plus plus and plus a. So a plus plus is a postfix operator. So this expression will operate as follows. We know a is 2, right? A plus plus. So we first evaluate it as a 2, then we increment a. So a now is 3. So 2 plus 3 is 5. And we'll assign 5 to the variable a. For the prefix operators, they are exactly the opposite of postfix operators. The value of operand on which they operate gets increased or decreased first. Then there is in the program. So when the operator or variable is used later in the program, the variable holds the new value obtained by incrementing or decrementing the initial value by 1. For example, on the right side, we have an integer a equal 3, so we assign 3 to a. The next line, a equal plus plus a, then plus a. So plus plus a is a prefix operator. So we will increment a. So a now is 4. Then we add 4 to 4 because now the a value is 4. So the result then is 8. Then we assign 8 to a. So in summary, for the prefix operator, the result is calculated and stored. Then the variable is used. For postfix, the variable is used first. Then the result is calculated and stored. For loop provides a concise way of writing the loop structure. Unlike a while loop, a for statement consumes the initialization, condition, and the increment or decrement in one line, thereby providing a short and easy-to-debug structure for looping. In this example, we assume that a variable named val, V-A-L, has been declared as an integer. The for statement shown in this figure produced the same output as the while statement shown below it. They both display the integers 1 through 10. We initialize the variable in use. It marks the start of a for loop. An already declared variable can be used, or a variable can be declared local to loop only. The testing condition is used for testing the exit condition for a loop. It must return a Boolean value. It is also an entry control loop, as the condition is checked prior to the execution of the loop statements. So once the condition is evaluated to true, the statements in the loop body are executed. We also have an increment or decrement updating the variable for next iteration. When the condition becomes false, the loop terminates. Let's take a look at a do-while loop. Do-while loop is similar to while loop, with only difference that it checks for the condition after executing the statements. In this example, the multiple statements in the curly braces block under the do will be executed. And then in the while condition, we will check the response from the user. If the response is the same as the number 1, then the do block will be executed again. If the response is some other number, the do while will stop. And pay attention, while response equal 1, so there's a semicolon after this while. If a loop exists inside the body of another loop, it's called a nested loop. In this example, we have an outer for loop for customer equal 1, customer less equal 20, customer plus customer. And the inner for loop is for color equal 1, color less than or equal to 3, then plus color. So we actually print 3 mailing labels for each of 20 customers. Loop optimization is valuable because programs in a loop takes bulk to time of programmer. If we decrease the number of instructions in an inner loop, then the running time of a program may be improved even if we increase the amount of code outside that loop. In this example, we decreased the amount of code in the loop. This transformation takes a statement or expression which can be moved outside the loop body without affecting the semantics of the program. For example, in this while statement, the limit -2 equation is a loop invariant equation. Of course, the limit will not be updated inside the while body. So the first statement, while I less or equal limit -2, limit -2 will be executed every time. So the code below that, after code motion, the result, we have a new variable a, and we assign limit -2 to a. So limit -2 only execute one time. Then we can evaluate with a while I less or equal than a. So make sure the loop doesn't include unnecessary operations or statements.